Alright, so today we're going to explain how to do volume in calculus. So first of all, we're going to go over kind of what a problem looks like and then the steps to solve it. So the first problem we're going to do is it's going to be what happens when you ask to have x squared in line x equals 3 rotated around the x-axis. Okay, so we're going to divide it up into 3 simple steps. So the first step is you're going to have to draw the graph. And then your second step is you're going to have to set up your equation. And then your third step is just going to be to solve. Alright, so first we're going to have to draw the graph. So first you just draw it, and then so it's line equals x squared, so it's going to look like that, and then you have line x equals 3. So you're just going to set up, it'd be better typically to start up if you have a line first, but since we know x squared is going to eventually hit the line, you can just draw it and figure out where. So, but you know that they're going to make contact at 3. So from 0 to 3, that's where you know that your interval is going to be. And then so you just kind of have to figure out the height at which they're going to meet. So if you throw 3 into the equation, you're going to get that this will meet at 9. And then so your entire area will look something like that. Alright, so now we have to find our equation. So the disk method allows you to use the area of a circle, which is pi r squared. As you see, since pi is constant, you'll take it out of the integral as you've seen here. And then so that just leaves you with r squared to get your volume times d times dr. So this is just the integral, this is the equation. You don't need to put too much thought into it unless you're going into deeper calculus. Just know that this is what it needs to look like. But the biggest thing is, what is r going to be? Because we have to plug r into the equation. Well, with r, it's always going to be something like this. It's going to be all of your circles going inside the area. So whatever area you've decided, your disk is within that area. So it shouldn't be all the way out here. It should just be right in here. So as you see, the radius is pretty simple in this equation, just because you go up to the line and then that's your radius. So it's just going to be x squared. You just have to be able to look at it. That's why we drew the graph, just so you can look at it and you can see it. So we're going to throw that into the equation now. So it's going to look something like this. So it's going to have x squared dx. This changes from dr to dx just since x is your variable. Alright, so the domain is just going to be from 0 to 3, since that's just where your area starts and where it ends, because this is the point of intersection up here. So it's just going to be from 0 to 3. And then next we're ready to solve. So what we're going to do is you can do a couple things. For now we're just going to put it into calculus. You're going to have to be really good at integrals, since this will often be on a non-calculator section. You're gonna have to figure out how to do this. But basically what you're gonna do is you're gonna go to the integral button. You're gonna set it up from 0 to 3, and you're gonna have x squared dx, and you're gonna solve, and then you just have to multiply it by pi. And then that should be essentially what your volume is. And then this should be equal. Okay, so now we're gonna do a different kind of problem. So now it's gonna ask us to rotate y is equal to negative x squared plus 4x and line y is equal to 2x around the line y is equal to negative 1. So for this, you can pretty much ignore this here. This is kind of the difference between what we did before and what we're doing now. But now you can redraw it. You know, the line y is equal to 2x, that's a straight line, so that's y is equal to 2x. But you kind of need to check out what y is equal to negative x squared plus 4 is. So as you can see by the graph, since y is equal to 2x is a straight function, that means it must be the Bode function. So you can just draw it like that. It doesn't need to be perfect, but you know that this is y is equal to negative x squared plus 4x. So now you know this is your top function. I think that's the more important part. That's what you're trying to figure out. So shade in your area, make sure you shade that in just so that you can know. And then when you look at it, when the point of intersection here is going to be at 4, so that means your domain a to b is 4. Okay, so you still have your parent function that's here, and then we just need to modify it because of this whole clause over here. So this is your equation now. It might look a lot different, but it's really not. Basically what you're doing is you have the radius, because it's in 2 different pieces, and you just have to subtract whatever this value is. Okay, now I know that sounds difficult, but you just need to know that you're essentially doing the same thing, except you've broken up your 2 functions, and you just need to subtract your top function minus, so you're gonna have your top function, and then you're gonna subtract it from the line that you're rotating it around, and you square that value, and then you subtract it from the g of x function, or your bottom function, minus this value too, and you just square it. So you're essentially, it's just basically an expanded form, and then you have these thrown in there too. It's gonna look, it's basically doing the same thing, except you're rotating around a different value. So we're not gonna solve it, but we're just gonna set it up. So like we said, we know that the y is equal to negative x squared plus 4 is your top function. So we're gonna start this. So we know pi, and then we know our domain is 0 to 4. Okay, so the top function is your f of x function. Just always remember that. This here is your top function, and this here is gonna be your bottom function. Okay. And then, so you know that your f of x function is negative x squared plus 4x minus negative 1 squared, okay? And then you're gonna have your g of x function, which is 2x minus negative 1 squared dx. Okay, that's what it's gonna look like. It's pretty basic. You just need to remember this. You just need to remember what to do with this value. And it's that you're gonna take your top function and you're gonna subtract it by this value, and then you're gonna take your bottom function and you're gonna subtract it from the same value. Make sure they're separate. Make sure you square both of them. It's not super difficult, but you can kind of get lost in it if you just don't remember. But you definitely need to know this value. Okay, you can stop. Okay, so basically when you're finishing all of this, you just need to remember these equations here on the right. Your most common one is this one. This is your number 1 to know. Okay, this here's your number 2. If you have to memorize any of them, you gotta memorize these 2. Okay, these here are cross sections. So basically, and I'm gonna add one more. I'm gonna add the square is equal to a to b r squared dr. They'll ask you some random questions. You don't really need to understand what they mean. It's gonna be really funky, but basically you just need to know that if they ask you one of these, it's gonna end up looking like this. So these are all the different equations that you're gonna have to do. This is probably one of the most equation heavy units and concepts, because you just have to know it. It's much easier if you know how to plug it in, because you're gonna be asking yourself, oh, is it this or this or that? It's just easier if you just know it. But if you need to know anything, you know your disk, and you know how to rotate it around a line. Radius, 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 just make sure you have that radius. Like all of these, finding that radius is so darn important. And just make sure you know, remember the 3 steps. You draw your graph, you set up, and you solve it.